Welcome to another meeting here. Today I'm going to introduce two people. One of them is not here yet. Sarah LeGresley Rush, you all know, our new teaching faculty, and Chris Fischer, who is on his way back from ISB teaching. So he will join us in a few minutes, probably a little sweaty and out of breath. What we're going to talk about, as you can see, is about our curriculum, introductory physics. And I think that we're really, in the department, take a lot of pride in the innovation that we made in the last few years in our teaching. And we strive to kind of come up with innovative ways of reaching students that most of them don't really want to be there. And we still try to make it kind of interesting and engaging, so they actually like to be there in the end after doing this. Sarah is going to talk a lot, Sarah and Chris are going to talk a lot about what we're doing to improve student success, in both our introductory calculus-based kind of science classes and the algebra-based. And how we assess how well we're doing, things like that. One of the things that we do, because we moved most of our introductory courses to the ISB, and most of our faculty live here, we're trying to organize it in such a way that we do provide the best places on campus to our students, and yet use our faculty that mostly are here. So the motion between us and ISB happens daily, and the fact that Chris is not here is an example of this problem. Sarah.
Thank you. I'm going to assume you all in the back can hear me unless you say something. So are you good in the back probably? Awesome. Okay. So today I'm going to be talking about mainly our calculus-based courses. And specifically, I'll be talking about Physics 210 and 211. And I noticed some people from engineering are here, and I noticed some people from CTE are here, just to sort of tell you how our colloquiums run a little bit. Anytime you want to ask questions, feel free to ask. Okay, so you don't have to wait till the end. Also, we've tried to plan this so that there's a little bit of extra time at the end, so that, for example, students or faculty that have worked with these classes can maybe add to the discussion a little bit. So, first thing, we're going to be talking about student performance. However, we're not talking about basically the teaching proficiency or content delivery. So in other words, we're looking at student grades basically associated with the curriculum. So the data that we have is for classes that were taught by tenured full professors. So that's what the data we're talking about in our physics courses. So just talking about the curriculum. And that's basically what we've changed. So a little bit of background here. All the way up to about 2013, we had one version of our General Physics 1 class. And a little bit about our General Physics 1 class. It was the course number Physics 211. How many of you all had Physics 211 here? Okay, so maybe a few of you. Okay, so it's our classical mechanics and thermodynamics. It's actually calculus-based, so there's two versions. We have the 100 level that are algebra-based. That's not what we're talking about today. We're talking about the calculus-based. Up until 2013, it was a 4-credit hour class. So the 4 credit hours, 3 of the hours were spent for the traditional lecture, and then 1 hour is for the lab. It had a requirement by the School of Engineering. They required this course, as did several of the physical science degree programs. So physics required this, chemistry required this, atmospheric sciences required this. So a few of the sciences actually required this course. So around this time, we all started doing our course reforms, right? So we started changing basically how we deliver the content. But then we also said, well, now that we're improving the delivery, let's also talk about what the content actually is. So the School of Engineering said, and I wasn't here at this time, but the feedback I got was there wasn't enough calculus in 211. Calculus is a prereq for this class. And we should also increase the amount of coverage into the thermodynamics. The physics faculty said, well, we don't actually think this does a very good job of preparing our majors for our upper level courses. And we think that there's just too much time spent on the Newton's laws. So too much time spent on forces. So what happened was the faculty discussed, okay, let's start modifying this curriculum. Okay, let's have it include more calculus. Let's have it do maybe a better treatment of thermodynamics. So Professor Antoniuk and Professor Fischer, he picked these pictures, not me, they sort of sketched out what this new curriculum would look like. And then Professor Antoniuk ended up leaving KU. So we all agreed, okay, this is how things are going to work. We're going to have Physics 211, which was 4 credit hours, so 3 of lecture, 1 of lab, to incorporate more of this calculus and a better treatment of the thermodynamics. Let's split up the lab and the lecture and add the credit hour to this. Okay, so we took something that was 4 hours, we split it, made it into a total of 5 hours. And the hope was that additional contact time in the lecture, and I'm using the term lecture kind of loosely because we're moving to active learning, but we're moving more calculus and more thermodynamics into this portion. But as we know, things don't always go as planned. So this is what actually happened. We still have 216 that's broken off. We have 211 and we have 210. Now there are some engineering people here. I saw a few engineering people. My understanding of this is that what happened is the engineering programs are always under a lot of pressure to keep their credit hours lower. And so we had this 3 credit hour course. So that's what we ended up with. So what ended up actually happening for the 210 version is it largely became what Physics 211 used to be. Okay, so there was some additional time devoted to thermodynamics, but the problem is the textbooks in a lot of cases, they don't actually task the students with doing calculus very much. It's usually part of the presentation maybe, it's usually part of the text, but it's not a case of students actually continually using the calculus on in-class problems, homework problems, and on tests. So in spring 2015, Professor Fischer basically finished what was started and actually put this complete course together based on introductory Hamiltonian mechanics. Our chairman, Professor Hume Feldman, said, okay, that sounds great. Let's put it into 11. Okay? So at this point, Physics 210 and Physics 211, they're both doing everything active learning at this point. Okay, so we've all moved. Most of our introductory classes are taught in the active learning style. Okay, the big thing to note here, there are large differences in the class sizes of these two things. Physics 210, I think I looked, they average somewhere around 200 plus, and 211 has a lower number of students, somewhere around 75-ish. So part of the way we deal with that is we have funding for undergraduate TAs in the courses, so that sort of helps normalize the number of students that are in. So I keep talking about Physics 210 and Physics 211. Okay, so here they are. Here's a little bit of the side-by-side comparison to them. So Physics 210 is our 3 credit hours. It's 3 class meetings per week. And then our 211 is the 4 credit hours. So the way that gets worked is we still have a Monday, Wednesday, Friday class, but we add an extra 25 minutes to 2 of those days. Now, if you look in terms of the curriculum, what we call the 210 curriculum is force first, and I'll explain a little bit why that's true. And then this new curriculum that Professor Fischer developed is an energy first curriculum. That's what we call it. So what actually happens is to get into 210, students have to be enrolled in or admitted to the School of Education. That is a prereq for this class. So 210 is definitely all engineers. Okay. However, when we look at 211, what sometimes happens is, for whatever reason, an engineering student can't get into 210. Sometimes we end up at room capacity. Sometimes it just doesn't work because of their schedule. For whatever reason it is, we do have engineers that end up in our 211 course. So in terms of these curriculums, I said basically we're doing what we consider different curriculums. And the idea is when you see the Force First curriculum, which is what is done in 210, and it's done actually in a large number of textbooks, I think. They basically motivate the idea of classical mechanics starting with forces. That's why we call it the Force First. However, if you look at Professor Fischer's Energy First curriculum, it actually has this very overarching theme and starts with that theme of energy. So the other thing, mathematically, vectors are two-dimensional, scalars are one-dimensional. So with the Force First, because we're talking about forces, we end up talking about vectors very early on in the semester. When we talk about vectors, we delay them in this Energy First approach, okay? Because mathematically, we want to save that stuff till a little bit later on in the semester. And this is what I mentioned earlier, that students in the Force First curriculum, they don't do a whole lot of calculus. Where in the Energy First curriculum, students are basically doing calculus on almost every topic we cover. So the final thing is that when you start with this Force First curriculum, it seems like, and I remember taking this version of the 211 course actually here several years ago, and it seemed like I had to find a unique way to solve each problem. It wasn't this like, this is a general approach you take to it. Where now that I'm teaching out of this Energy First curriculum, it seems like because we're taking this overarching idea of let's just talk about energy, it makes for a little bit better overarching theme. And so you don't have so many specific strategies that you need to use depending on what type of problem you're solving. So this is actually how the chapters are arranged. So this, on the left there is the Force First curriculum. So if you notice it's in green, that's pretty much the standard approach. You start with forces, move a little bit to the energy conservation, then go back to forces a fair amount, a little bit of thermodynamics at the end. Now this Energy First starts, everything is energy based to start with. So spend a lot of time on energy, spend some time then on the force-based mechanics, and then combine them up when we talk about angular and linear momentum. And when it comes to the thermodynamics, it has actually, students are being required and tasked with actually doing calculus a fair amount. And so here's what I mean. So if you look at this, on the left side are all the topics that were covered in 210. So if I go back to this slide for a second, basically in this order on the left is the way I'm presenting them here. Okay? And what you're looking at is trigonometry, vectors, differentiation, and integration. Those are sort of the math skills that are required of the students. And again, this isn't just they saw it once in the textbook. This is you had to differentiate or integrate on your homework. So if you look, trigonometry required on almost all the sections. Vectors required on a fair number of the sections. But when you get over to differentiation and integration, the 211, which is that Energy First curriculum, that's requiring differentiation and integration a lot, right? Compared to the old curriculum.
For fluid dynamics and vectors, what's the S19?
Yes, thank you. So this, so when Professor Fischer originally wrote this textbook, there was not a section on fluid dynamics. He has since revised it, and coming out in spring 19 with the new revision of the curriculum, it will include fluid dynamics. That's the only question so far? Good. All right, let's talk a little bit about assessment. So we started looking at this Energy First curriculum and said, well, how does it change the learning now, right? How does it impact the students in this course? Do they do better or worse on things, right? Because we want to make sure this is a requirement for several degree programs. It's a requirement for our physicist, chemistry. It's required for School of Engineering. So all these students are taking this class. Technically 210 is required for School of Engineering, but we know we have engineers in 211. And we want to make sure whatever it is that we're doing, we're actually trying to at least make sure our students are doing as well as they were in the previous curriculum. So what we decided to start with to sort of look at this is what's called the Force Concept Inventory Exam, or FCI. It's a 30-question multiple choice test, and the idea is to measure how well students know the concept of forces, not surprising. So we started collecting data. We have a total of 3 semesters worth of data for 210 and 211. Started back in 2016, and again, this is where I sort of did my mention at the beginning. This is all data from instructors who are full professors with tenure in our department. The data was aggregated, and we wanted to look at it by ACT score. So in other words, how do students with different ACT score basically do on this FCI test? Just because we know there is a correlation between mathematics ability and FCI, what we call gain. So what we look at is gain, or in effect, it's actually normalized change, and this is how it's calculated. We take the post-test score minus the pre-test score. So the difference between those is basically how many more questions did they get right, so how much did they learn, divided by how much they could have learned. Okay, so the pre-test and the post-test looks exactly the same. They take it basically the first week of class, they take it the last week of class. Same questions. So this allows us to look at the normalized change. There's a couple special conditions if for some reason your students don't do as well, and if we have 0 or 100%. But in effect, we're looking at how much knowledge they have gained divided by how much knowledge they could have. Does that make sense? Okay. And this is our graph and data of this. So if we look at this, so across the bottom here, we see the ACT math score. So less than 20 to 22 to 24, 25 to 27, 28 to 30, and more than 30. And this is how much they gain on this FCI score. So what you can see in the blue is the 211 students. So the students with this energy first curriculum have higher normalized gain than the physics 210 students. Yes?
So some of the physics 210 students lost knowledge? Is that how we interpret that negative point?
Yes.
Okay.
Yes. That is possible. So one thing I will say is when we compare this to national results, and with the way it's been given nationally for I think the last 20-some years, thousands of students, probably tens of thousands of students have taken this. They ask that when you administer this, you don't tie points to correctness. Right? So you make it a 0 stakes test is what they call them. So basically we tell the students, please, because you want to take this test. But we're comparing that between the 2 classes, so we're giving sort of equal treatment to both classes. It's sort of up to the students to take it seriously. Most of us tie some extra credit into it, but it's hard to just make them, because we want to be able to compare the national. Yes?
Is there any differentiation for students who had physics before they took physics 210 or 211? So if they brought in 115 or 114 from the AP?
No, there is not. Anybody want me to repeat that question? The one thing is that should in effect get accounted for in this when they look at the normalized change, because so for example, for a student that came in knowing a lot, we're basically normalizing by that because they would have a higher pretest score, and this is basically how much they gained, and this is how much they could have gained, because if they came in with a lot of knowledge already, they would have a higher score here. Okay, so Not surprisingly, the normalized gains were correlated with their math ACT scores. We actually like to see this, for example. So we're seeing down with our students with lower math ACT scores, we're seeing a higher gain in their conceptual knowledge. Yes?
So this is normalized gains. I'm
Yes.
curious how the starting physics knowledge compared between 210 and 211.
Yes, thank you for asking. That was in my notes to make sure I mention. So it turns out when we look at these two populations, we didn't bother to put the a graph on here, but I can pull up the exact numbers. We have a slide at the end. When we look at the math ACT scores for these students in 210 and 211, when you look at their uncertainties, they are basically within the uncertainties. 211 might be a little bit lower with their starting ACT scores.
Basically, it is the same starting population of understanding.
Yes, yes. So the math ACT score, basically the same. And if you look at their pretest scores between the two classes, they also overlap with their uncertainties. So we think they're more or less coming in with the same math and the same average pretest score. Yes?
Yeah, what fraction of the 211 take both exams compared to the 210? Because if you're only getting like 10% of the people from 210 actually taking both the pretest and the post-test.
Small number statistics is what you're asking? Yes.
So the fraction of the people available to take the class, how many are taking both the pre and the post test?
This data, as far as I'm aware, and Professor Fischer's here so he can help correct me if I'm wrong, these are only students that both have a pre and post test.
Right, but what fraction of the 210 class is that? What fraction of the 211 class is that?
If I look, so this is actually a little bit pared down version of it. So in this analysis, we're including 377, 210, and 147. The reason is we don't have ACT scores for all of our students.
Right, but what fraction? Is the 211 class, is that only 15% of the class, and the 210 is 50% of the class? Because the relative fraction of the people in the class is very important in this statistic.
Yes, I would say when I look at, so the tests all come through me, I would say we can match up somewhere around 80 to 90% of them.
In both classes. So 211 has 80 to 90% and 210 has.
Yes, if I had to guess. Phil, you've taught that. Does that sound about right, or you just give me the test?
Just the one time I did it, yeah, it was probably
In the 80 to 90% range? Yeah. Yes?
So it's interesting that you use math ACT score. I suspect many of these students, it's at least their second semester here at KU. So some of those 28s to 30s, this could be the first semester, they could have come in, and or they started at Calc 1. Everybody below that started at pre-calculus. So did you also look at correlation to Calc 1 grade, for instance?
We have not looked at their correlation to Calc 1 grade, but we will talk about how they do in downstream classes. Yeah. Yes.
Having taught the 210 for
Yes.
a couple of these terms.
Yes. Oh, thank you. Yes. Some of this is your data.
Yes, and we did not, I don't know about the other section, but I know for at least some of these, no extra credit was given at the end. And I know that possibly because of that, a significant fraction of the students blew it off.
Yes. So,
Wait,
yes. So this is in my yes but slide. Okay. So I'm ready. I'm ready. But thank you for bringing these up because we want feedback. They might have larger normalized gain for, this is one of the things we thought might be key. So if I start learning about forces halfway through the semester, I don't have to retain that knowledge nearly as long as someone who took it at the beginning of the semester, right? So we said, yeah, okay. Does that make sense that you only have to retain it half the semester, not the entire semester for the post-test? So the other thing, we're not saying the FCI is the end-all be-all test. We're just saying people have given this for the last 20-some years. We can compare it nationally. It contains no quantitative problems. So we're not asking them to do any calculus. And it doesn't include thermodynamics. right? So there's some flaws with just claiming the FCI is saying this is better. There is likely some selection bias since students complete the exam for extra credit and, as you mentioned, sometimes not extra credit, right? So the one thing I do want to say, because I don't know if it's going to come up, you should come up because you're going next. The one thing I will say when we looked at this score is when we look at the number of students with the number of DFW rates in 210 and 211, they are basically comparable. It's the same percentage of students. So we were concerned that we might somehow be weeding out some of our students because it does require more calculus maybe than the other class, but we actually don't see that in terms of the number of DFWs. Okay. You're up. Oh, I have to give you this though.
I can shout really loudly.
No, it's for the recording.
Ah, okay.
So you do have to do
No shouting in physics. I am sorry that I am late. I teach over an hour before I come here. And this is as soon as I can make it over here. So that is the way it is. Okay. Let's see here. Yes, so as Sarah mentioned, we did the FCI exam as an analysis tool because a lot of people in physics education research use the FCI exam. I think all of us in this room have already identified several flaws with this test. You know, do the kids take it seriously or not? Is it expansive or not, et cetera. So we've tried to think of other ways of assessing student learning besides the FCI exam. And one thing we thought of, and this is working in collaboration with our friends at CTE, is can we look at grades students achieve or earn in downstream courses? So this is a model of what we're looking at. Most students that we're going to talk about here are taking Calculus 1 in their first semester. In the second semester, we get them for Physics 1, either 210 or 211. So there's a split of these populations of students. There's only one Calculus 1 class, that's not honors. But then we break the students apart to take 210 or 211. Then they come back together again, the students come back together again in their third semester or later to look at downstream courses. So the students have the common initial math class and the same downstream class, but they have different Physics 1 classes in between. And one thing that's kind of nice about this is that we are immune from things like changes in Math 125 affecting our results, or changes in the downstream courses affecting the results, because we're just comparing two groups of students in the same courses downstream. What happened to them? And the only, a major variable that is taking place is were they in 210 or Physics 211? So we hope and assume that students are trying to earn the best grade they can. So therefore, the grades they earn in the downstream courses should be a good reflection of their ability, if not their actual learning or interest level. Questions about this? Yes?
Do any non-engineers take the 210? Because you did say...
No. Well, no, you have to be admitted to the School of Engineering. Now, it is possible someone drops out while enrolled in that class, but no.
There are also some engineers that take 211.
Yes.
So if the only comparison is, the only comparison you can make across that would be sort of fair between these students who are in engineering. Because if he takes a physics student who may take a bunch of other physics courses, then that's their knowledge.
Right, so we have to be comparing students who are in the same downstream class, but who took different Physics 1 classes.
Right, there may be other classes that a physicist would take in 211, and engineers might not take in 210, that
Yes.
might reinforce.
Yes, there's probably a lot of hidden variables here that we can't control for, but this is sort of our best first step. Question?
Are these consecutive semesters, so the student could not fail 125 or fail Physics 210 to begin their study? Or?
We can't control for the 125. We can control for the 210, 211 consecutive semester for the downstream course, but we didn't control earlier on. And the reason why Sarah kind of indicated this, it got kind of frightening fast talking because we want to look at matched students. A student who took 211 took this downstream class. How do they compare? And we want to have it be the case that they took 211 once, took the downstream course once. What did we see? And with the Math 125, given the fact that class has a slightly above average DFW rate, you have a whole lot of permutations of people who are getting through the calculus sequence while fitting to the physics and engineering sequence. So when we tried to go down the road of compensating for that, there were just a lot of special cases. Do you want to consider students who took Math 125 once and then physics, or they took it twice and then physics, and this kind of stuff? And we just sort of gave up because it became just too small groups and my head started to hurt. But the 210, 211 to the downstream course, that is a sequence that you were taking in the next semester. Okay, so the first thing we looked at was physics 212 because we're biased. So students who take either physics 211 or physics 210, what happens to them in physics 212? So physics 212, this is general physics 2, electricity and magnetism, electric circuits. What we did in this analysis, we didn't do it. Okay, what our friends in ORIP did in this analysis is they aggregated grades that were earned in physics 212 since the summer of 2015 through the fall of 2017 by students who had taken either 210 or 211 in the previous semester. This is a nice little workbook that was made for us in visual analytics, everyone's favorite program to use at KU. And so we had OIP average those grades for us. We then further parsed everything by student ACT math score, because in the literature, like this paper, for example, which you can't read because it got messed up with the page number, but there's plenty of evidence that your ability to do physics well correlate, your grades you get in physics classes correlate with your math ability, whether math ACT scores, the math component of the SAT, or your previous calculus course grades. So we're going to break things down by ACT math score again. So here's our slide for the physics 212 data. So on the bottom, we're showing the ACT math score binning. The vertical axis is the average grade that was earned in physics 212. Blue is physics 211 again, and red is physics 210. So we have a lot of students doing this because now we're taking advantage of almost all of these majors that require both general physics 1 and general physics 2. So we have 700 physics 210 students and 300 plus physics 211 students. So what we see in the data is that the average grades earned by the students who completed physics 211 are higher than the average grades earned by the students who completed physics 210 for each math ACT. Yes?
So am I looking at this right? There's no people in 211 who had 29 or higher for the math ACT? There's no blue dot?
Yes. And so I have gone through visual analytics many times. I've asked them if there's a programming error, and they claim this is true. So I don't know if it's the case that we have students who are taking 214 as an honors class and doing this. I know that EECS students don't take physics 212. That's part of the population. But I find that hard to believe. But whenever I query about this, I'm told this is correct.
I can't believe that. That's basically one unit of ACT math score is worth 1.5 grades.
So shockingly, I have a slide about that.
Huh?
I'm getting to there. So first, you can say, the lower ACT math score, the bigger this improvement is. And you say, well, that as our mathematician pointed out, yes, because you have two curves that are convergent on a point, so therefore the difference has to get smaller. But to raise Graham's point, it's almost as though you're shifting ACT math scores around by the class. So by taking 211 versus 210, it's almost as though you've had a default improvement in your math ACT score by 1 point.
I'm more worried about
Going up and down? Yeah. So,
Great.
yes.
Can you go back to the previous slide? Previous. Go further. No, I want to see the other, before this, there's another plot.
The FCI.
Yeah, this one.
Yeah.
But this one looks like you do have a lot of students in K 11 who has, greater than 20, even 30.
Right. So I don't know why.
And then the 210, you do have a lot of students who have scores less than 25, for example. But on your next, the plot, there's no student, in 210 who has, basically less than 27.
Right. So this is why I have had many. Right. This is why I've had many chats with our friends in OIRP, and they claim this is correct for matching students. All I can think of to try to justify either they're making a mistake, okay, or it's the case that because we asked to look at matched students, there is some screwiness with students who are taking both of these classes in a semester by semester sequence at our university. So they're taking 212 somewhere else. Some kids in 212 are taking 211 somewhere else. I don't know. But I've asked these questions, and I'm told this is what the data is.
It's hard if we imagine everybody who has the SAT less than 28 will just stop taking next course.
I agree.
And everything to 11 who has a score SAT greater than 29 suddenly dropped off. That doesn't make sense.
I agree.
There's also the part I brought up is what fraction is this of the people who got B's in 211 actually took 212. And so, and just like your original thing, if you're getting a selection bias. So for instance, chemists probably don't have to take physics 212. And there's a whole bunch of engineers. So you're actually getting a selection bias where you're only taking a certain fraction of the B's. And that fraction of the B's may be only 10% of the people in physics 211. So you're of the B's in physics 211, then you're actually seeing what happens in physics 212.
Sure.
So you actually have to see what fraction this is of the grades that you got to see whether this is representative of the whole sample or whether it's just some 10% fraction.
Right. I mean, I agree. We, unfortunately, all we can do is send queries to IRP. They won't let us look at the actual data. So if we ask them, please tell me what are the aggregate grades in 212 from students who took 211, this is the data that they give us.
You can ask them the numbers. You can say how many people were in this sample.
Yeah, we have the numbers.
Right, but that number has to be of the people who got B's in 211, how many of them actually took 212? And were in my sample for 212.
We could probably get that.
You could ask for the full grade distribution, right? In 212.
That'd be,
And in 211. Things we can control in-house, we can do, but once we get to this, we don't do that within our department anymore. Because we don't have access to anything.
the university controls the data, so we have to send them questions that they send us the answers to.
But so can you explain, though, actually your data points and your confidence intervals on this? So that's not, so, because it looks like there's like a perfect correlation where if you have a 28, you got a D in a class. It'd be better to look at like the standard deviation.
Sure, this is standard error, but we could plot it as a distribution if you wanted to.
Yeah, I think that's more useful.
So I have a question. Because the average ACT in engineering is above 28, how am I able to tell, like, is that D 12 people? Is that D 112 people? Compared to the 29 and above ACT, it's hard for me to assess how many humans are in that dot.
Sure.
And that would tell me more information.
Sure.
So when I was asking about the 210 and 211 engineering and non-engineering, this is sort of what I was thinking about with what Alice was asking about, the selection bias. So if you could get numbers for people who took 210 who were also engineers, you could get out at least the major bias. You can make to, by electrical engineers, structural engineers, by different majors there, or even just the department as a whole. Engineering students in 211 only, you can remove some of the selection bias.
It's about 20% right now. 20% of my 211 is engineers.
Does that include students who were dismissed from engineering before that class?
I do not know because in all I can see is enrollment pay, and I did look, and it's about 16 to 18. Some of them, 2 of them were pre-engineering. I think 16 were engineering, and I have about 80 total right now. But that data is not included in this.
Question, Graham?
Well, I keep on looking at this and I think I can't believe it's true, but it depends how many data points are, how many individuals are in each data point. If there's only one individual in that point of 28 feet, then maybe the error on that is in fact 0, so that's fine.
Well, later on we have some that have.
But if I look at that and go from an ACT math score of 28 and physics 210 and I get a D, and I go to an ACT math score of 29 and I get
I think Alice's point, maybe by applying this as distributions would be more meaningful. Okay, so assuming there is a difference, going with that assumption, why would there be a difference? So one thing you could argue is you could say that if we believe the FCI data, then maybe the students in Physics 211 learn the physics concepts better than the students took Physics 210, and therefore they do better in downstream courses. So my only problem with that is a prejudice problem where I'm not exactly sure how much of an improvement in your knowledge of E&M would I correlate with an improvement in your knowledge of Newtonian forces. We can make arguments about math competency and intellectual maturity, but I'm not exactly sure the FCI test would be alone to justify that change. Maybe if you enroll in 211, you are better prepared for the applied mathematics that you use in Physics 212. You can use vectors better, which is helpful for E&M. Or maybe you're better at some of the applied calculus. And that'd be consistent with other literature which shows that there is a correlation between grades in Physics 2 and math ability. So maybe somehow we're helping students with their applied mathematics skills, and that results in better grades downstream.
I have a quick question about math skills.
Yes.
Is there any mathematics department standardized testing that's similar, where you can say, look at their physics stuff and see how they do with math courses later?
So that's a good question. There are standardized math tests, and we'll talk about this a little bit later on. I believe it is not the case that the students cannot do math. I think it's the case that they're unable to transfer those math skills outside of the math classroom. So if you give them an integral and say, solve this integral as a problem, they can do it. If you give them a word problem that requires integral solution, they can't do it, even if it's the exact same math in both cases. So maybe, and this gets back to what Jennifer is working on in the labs, is can you come up with an assessment, in her case for the lab students, that looks at their ability to understand physics concepts within the confines of a discussion in the lab with lab terms and physics words versus a bleached problem that just talks about cats and dogs, but still involves quantitative analysis. Something like that could be amendable to what we're going to do. And of course, there could be any other reason that explains this, including just like poor analysis of the data. Okay. So then we thought, fine, we could take advantage of the fact that we have engineering students in both of these classes. Most engineering students take Physics 210, but some take Physics 211. What happens to these students when they leave these Physics 1 classes and take courses within engineering? So now we can try to do a better job of comparing populations of students that are a little more equal to each other. I went and looked up what are the courses in the School of Engineering that explicitly require Physics 1 as a prerequisite. There are 3 courses. Mechanical Engineering 211, Statics Introduction to Dynamics. Mechanical Engineering 312, which is Basic Engineering Thermodynamics. And then CE 301, Statics and Dynamics. So these 3 courses all require Physics 1 as a prereq, either Physics 210 or Physics 211. Yes?
You get to the point a little early. Do you have a control group that they have to take that does not require the Physics 211 to see if there's similar increase or decrease in performance?
Yes, we do.
Okay.
That's an excellent question. So these 2 classes all require Physics 211. They all have a General Physics 1, Physics 211 or 210. They are classes required for majors within engineering. So hopefully the students are taking these courses seriously so we could see how well they do. And these courses are also prereq courses for other classes in engineering. So we were curious to look to see what would happen to students who took Physics 210 or Physics 211, then went on the next semester to take one of those 3 classes. When we looked at parsing this data by ACT math score, again, using the data that we got from OIRP, they told us that we looked to see that students who had an ACT math score of 30 or higher got an A in all 3 of those classes, regardless of whether they took Physics 211 or Physics 210. In some cases, there were no students who had math ACT of 30 or higher who took like 211 and then ME 312. But in all cases where we had data of students who took 210 or 211, then went on to take these engineering classes, if their ACT math score was 30 or above, they got an A in the engineering course. So we looked at what was the data for students lower ACT math scores, 25 to 29. We picked 25 because that was the lowest end that we had for our data. So here's the first group we looked at. So here I'm trying to show the sequence of courses you would go through to get to ME 211 or ME 312. So again, you start with Calculus 1. Students take Calculus 2 in the second semester along with General Physics 1. Third semester, they're taking Math 127, ME 211, ME 312. There is some variation with ME 312 because it is also allowed as a substitution for some other degrees in engineering besides mechanical engineering. But for the most part, this is what a lot of the students are doing. So ME 211 and ME 312 have a prerequisite of 210 or 211. So we're looking to see what happens to the student grades in ME 211 or ME 312 based on whether they had Physics 210 or Physics 211. Questions about my little flow chart here? Okay. So here's the graph. This is the graph that Michael Moore designed for us. So what we're plotting is, on the horizontal, it's the average grade earned in one of these classes by students who completed Physics 210. The vertical is the average grade earned in these classes by students who completed Physics 211. And this cohort, again, is students who have the ACT math score between 25 and 29 inclusive. The dashed line would be if they had the same grade. So if a student who took 211 and a student who took 210, if they had the same average grade in the downstream classes, the points would all lie along the dashed line. So we looked at these three engineering classes to see what happens to them. So first we have ME 211. So there were 59 students who took Physics 210, and then the next semester took ME 211. This is over several semesters. It's not one-to-one. And then 79 students in Physics 211. If you make a plot of the average grade earned in ME 211 from Physics 210 students versus Physics 211 students, you get a difference of 0.8 on a 4-point scale, so a little bit less than one letter grade difference. So ME 211 students seem to do almost one letter grade better if they've had Physics 211 rather than Physics 210. And again, this is just the students who are in the lower ACT math range. The ones who are higher, they're getting A's. Here's ME 312. So we have several more students involved in this analysis. And it's a smaller improvement. It's about a little bit less than half a letter grade improvement. And then finally, questions about this? Yes?
What are the average grades in these classes?
What are the average grades? So the average grade for ME 312 for these kids is around a C, but then you have a lot of kids who are getting A's, so I'd have to go and calculate it. Because when I pulled up, I parsed the data, so I have to go back and add all of it together. What tends to happen is there are these, since all the students who have ACT scores of 30 above are getting A's, these differences go away if you say what's the average for the entire population. Because you pull at least, it varies from class to class, but it's between a fourth and a third again of the no, that's too much. So between a fourth and a fifth, maybe again, the population is in these higher grade earning categories.
Isn't it remarkable that 59 students got an average between a D and a C in this class?
Yes, but I don't do grading in the School of Engineering, so I don't know how. I don't think that worked out.
Is the average grade in this class a C?
No, it's higher because there are students who are getting A's who are pulling the average up for the whole class.
How many students take this class?
I'd have to look up the total enrollment for the class. I don't know. I have a slide at the end that talks about that. If you wait, because I talk about DFW rates, and there it talks about the number of students per class per semester. So I can get to that. Yes?
There must be some strange selection going on here because 210 is the course most engineers should be taking, yet there are fewer going to the 211.
Yes.
To ME 211 than from Physics 211. So,
right. So
what's going on there?
Why could that be? So it could be the case that for whatever reason, the students are mechanical engineering students are disproportionately enrolling in Physics 211 rather than Physics 210. That's possible. I have to look at schedules to see if that makes any sense or not. It's all.
According to your previous figure, there's no student in the 211. physics 211 who has the SAT greater than 29. That means
Well,
that you exclude your people who have
No, there's,
SAT greater than 30, which they're all got 8. Does that mean whoever took in the physics 211, then now wouldn't get 8?
so what this data is showing, which again, I am reporting what I am told by OIRP, and I'm not allowed to see the actual data. But they're reporting what matched students are. That does not mean there are not students who have different ACT math scores. They're just not matched within the database from taking 211 to 212. So when we come down here and look at these students, these could be different populations because I'm not putting a different matching requirement to OIRP.
Also, these people did not take 212. So.
Well, most engineering degree programs require physics 212. The only ones that don't are ECS students. Now, it's possible some of the kids could take physics 212 at JUCO over the summer. And I can't track that, you know.
But where are all the B's? I know that Chris already brought this up, but I don't know, this was bothering me too, that it seems like you have a binomial distribution of A's and B's.
That's what I tend to see in my classes.
Is it? Okay.
Yes, a lot of times I'll see what I would consider a bimodal, where you have a lot of students here, and then you have a dip. It's almost like a reverse bell curve to a certain extent.
Another problem with a lot of this, and I'm not picking on anyone in particular, but you know, there are inherent problems when you grade courses with curves because you screw up all your distributions a lot. And so it'd be a lot better to move toward a more objective-based grading system for these classes because then you could more effectively look at comparisons between results. Because if I've got a bunch of kids, that's a horrible word. If I have several kids who are getting A's, they're setting a curve for the class. That's going to mess up how the rest of the distribution falls out in the class. Yes?
So, on the point of the bimodal distribution, if it really is so far from the normal distribution, I think that maybe just the average and standard error is simply not a good metric.
Sure.
And fractions, they get A's, B's, C's,
Yeah.
so on. And on another point, you make a big deal early on that physics we have these standardized inventory exams, and I assume that is maybe they do a sort of curve for that too. I'm not sure, but I assume the score is just a score for those inventory exams. And engineers at a certain point have engineering exams for getting engineering certificates. Is that something?
Yeah, that's like senior year level stuff.
So there's nothing but grades to look at for engineering courses to have
We could look at the distribution of the grades as a better way of presenting it, but otherwise, no.
standardized testing that they take similar to the.
Not that I know of in these classes. And the further away you get, the problem is that there's going to be other courses people are taking that are influencing things. It's bad enough that we don't know exactly how maybe there's a correlation between 211 enrollment in your math 126 or 127 grades that could affect this as well. But the further down you go in the chain in the years, the effect is going to be really, really hard to parse out. Yes?
Have you looked into the effect of students that drop engineering major? And what percentage of that is due to increasing the top level?
So one of our next rounds is going to be we can get some macroscopic we can get macroscopic F and W information, but to get D, we have to make another request to OIRP. And that's one of the things we're going to do. And we have to make that, again, we'll probably break that down by the student's major. Yes?
If you're going back to OIRP, you're missing about 120 engineers in CPE 221. Physics 210 is required for that course.
Is that relatively new?
No, it's their filter.
Okay, I'll have to check that out. All right, then we looked at CE 301. This is civil engineering statics class. So again, it's taken in the third semester. It looks similar to how the ME 211 course stacks up. If you look at where those kids fall, again, it's a much smaller number of students now, but it's a similar sort of change to what we see for ME 312. So a little bit less than half a letter grade difference. So for these three classes we looked at, within the limitation of this analysis, the students who are taking 211 are doing better than the students taking 210.
And so one of the reasons could be that they were taking 4 credit hours
Yes.
instead of 3, and
Yep.
it had nothing to do with energy
Yep.
versus force.
Yep. Yep.
And that the engineers should require them to take a 4 credit hour physics course because they'll do better in their classes.
Yes. Yes. We're gonna have a slide of conclusions, which is more like me going, about what this all means. But it's mainly, there's a lot of things we could think about doing to test what's going on here. Yes?
I was going to comment, this also doesn't include the students who got A's in those courses, right?
Correct.
So what's the portion of students who got A's in physics 210 versus the portion of students who got A's in 211?
This is, what I'm including here is, this is everybody that ORP tells me has a math ACT score of 29 or below who takes 211 or 210, then takes CE 301 or ME 312.
No, but I think he's asking, if you take physics 210, how many people got A's in physics 210? How many people got A's in physics 211?
Yeah, we can do that. Right, we can do that analysis, that's fine. One concern I have about that is that just like I don't have a whole lot of faith in the FCI as a test because for many reasons. If I want to look at comparing a grade that's earned when Steve is teaching a class and Michael's teaching a class, and I have no idea how they're weighting or curving any of the assignments, I think it's it makes it a little bit harder to interpret what that might mean. Whereas in this data, I'm saying these kids went on to take ME 211, and I assume they did their best. And some of them had 211, some of them had 210 to begin with. What happened now? So I'm hopefully trying to average out variations in people's grading preferences and curving and everything else. But we could look at the grades coming in, but then there's an additional level of, I don't know how to interpret that because I can't compare necessarily an A in 211 and an A in 210 because the content is different, the grading is different, the weighting is different.
So this is quite impressive, but one issue might be within the 2 subsamples. I know you control for ACT math score at some level, but given the variations you showed before, there could still be half a unit difference
Yeah.
in the mean ACT math score in the different subsamples.
Yep, so we could break it down further. When I've done that, you get the same results, but the error bars get bigger and bigger and bigger because I have fewer and fewer students in my little populations. But the trend holds for all of the ACT math scores. Another problem you have is that because we don't have that many students, like we have 47 here, I don't always have students who have all the ACT math scores. So there's a lot of gaps in my data as it goes down. But we could do that. Okay, yes?
How many semesters does this include?
This is starting from summer of 15 through fall of 17.
6 semesters?
Yeah.
So ME 312 probably has 150 students per semester, so the fact that you only have a relatively small number would possibly suggest that a student who actually got a grade in thermo, right? A very high portion of those got A's in physics 1.
Possibly.
Is that-
All right. We can then break this data down by distribution. Probably should have showed this earlier then. So here we're looking at the distribution of grades. Number of students is on the vertical. The letter grade that they got is on the horizontal. For the 3 different classes, this is summed over all the semesters we've looked at so far. For the students who have the ACT math scores 29 and lower. So I mean, if you're 30 or above, you've got an A. So they're not on this chart. There's just the lower end people. So things that interest me notice is that it sucks to be in ME 211 because no one got an A if your ACT math score was 29 or lower. Same is true for CE 301. The only students who got A's in ME 312 in this cohort of ACT math scores are students who took physics 211. Likewise, the only students who got B's in CE 301 or ME 211 were students who took physics 211. So there seems to be an overall shift in the distribution towards higher grades associated with being in physics 211 versus being in physics 210. Now, the asterisk means you get an incomplete or withdrawal or a WP, which I forget what that means. withdrawal path. I don't know what that means, but it's incomplete withdrawal. We can't get data on drops from OIRP through this request to OIRP. It'd be a separate request. But it's interesting because if you look at this, then you can't talk about a DFW rate, you talk about an FW rate, which is not the same thing. But if you compare within these populations, the FW rates are lower for the Physics 211 students than for the Physics 210 students. So now I'm looking at just the population with the ACT math score 29 or below. Of that fraction, who's getting an F or the asterisk, which is withdrawal and incomplete. When you look at the data, I can't tell if it's a withdrawal incomplete, but I would just naively assume that withdrawal is larger than incomplete. Maybe that's wrong. So this is a FIW rate. Okay, I'm sorry this is taking too long. Let's speed this up. So why the difference? Okay, well, it could be the students have a better understanding of Newton's laws and forces. That's what the FCI exam told us. So maybe that's why they do better. It could be the case that since we had more thermo coverage in Physics 211, the kids do better in MB 312 because they've seen more thermo. Maybe. It could be the case that somehow their math ability's gotten better. It could be some other number of reasons. There could be a lot of selection bias in this. But the kids seem to be doing better. So we want to try to see, could we test any of these things at all differently? So to answer Matt's question, we picked AE 345. This is a class taken by aerospace students. It does not list Physics 1 as a prerequisite. But it is taken in the semester immediately after students take Physics 1. So it's the third semester class, but it does not require Physics 1 as a prerequisite. Even more fun is that we didn't talk about fluid dynamics or statics at all in Physics 211, but it is covered in Physics 210. And we can quibble about whether the fluid dynamics that we talk about in Physics 210 is appropriate for this or not, but at least that broad category of concept is not covered in 211, but is covered in Physics 210.
So is this something that has a prerequisite in engineering that requires physics indirectly, or?
I will show you the little chart.
Okay.
Here's the chart. So there are co-recs with CE301 or DiffyQ. So that's a problem because if we're affecting either of these two and we know we affect this one, we could affect this. I don't know how to weigh co-rec versus pre-rec. I don't know what what the term is in the series expansion for that, but there is no direct prereq for A345 for 210 or 211. So we're going to look what happens to students who take 210 or 211 and go on to take AE345. I apologize in advance for this because there are exactly 4 students over the past 6 semesters who have gone through this. So that's not good. And they all got the exact same grade. They all got a B. So, I'm sorry, they all got a C. So I don't know what to do with that. But again, there is a slight improvement, like maybe a third of a letter grade for the students who took Physics 211 and then AE345 versus those who took Physics 210 and then AE345. So again, why is there a difference with this? You could argue it has to do with physics concepts. The only issue with that is that I don't know what concepts we're talking about anymore because there wasn't anything directly relevant in 211, but there was allegedly something in 210. It could be the case that this is linked to how they do in CE301 or how they do in their math classes. That'd be a whole separate inquiry to our OIP friends to figure that out. Or again, is it something with math skills? Are we doing a better job prepping our students with mathematics skills in 211 that they do better later on?
So I don't know what the engineering curriculum schedule looks like, but are there any like English or non-science or math things that they would take past this point that you could also run a comparison? Just to see if there's sort of a general intelligence factor difference or something, maybe?
By the time you get to 3rd semester, a lot of the curriculum engineering is engineering courses. I mean, you could identify probably some kind of general education KU core class, but that's going to be the same thing where we're going to have 1 or 2 people because we're never going to find a common one they all took. It's a good question, but I don't know how to do that. Think about that.
You could maybe like show the distribution of their grades, but like weight it by their GPA or something, just to show what they generally are students.
Sure. Then we got to decide if we're going to weight it by engineering GPA or by KU overall GPA. I mean, we have to decide how we want to parse the data. I don't know what the best way of doing that is. Conclusions. All right. All metrics we employed, however flawed they may be, it seems like enrollment in Physics 211 is correlated with better student performance than enrollment in Physics 210. FCI exam, Physics 212 scores, scores in engineering classes. 211 kids seem to do better. Is it because of course enrollment or contact hours? Class size is different for the two classes, but we have the same ratio of UTAs to students, so maybe that mitigates a little bit. Next 25 minutes of class time doesn't seem like a lot, but maybe it is. Maybe that really makes a big difference. Or is there some kind of positive feedback between how well you can do physics concepts and how well you can do applied mathematics? And we're giving the students a better framework to work on those different skills. Just quickly, so there is plenty of data. Here's 2 papers I've written about this that shows that students struggle with using vectors correctly. Anyone who's taught these classes knows this to be true. If you want to really depress yourself, go read some of these papers. You will never sleep again or drive over a bridge. All right? So there's lots of that that's bad. So maybe, and again, this is me speculating. This is not anything that I've concluded with any kind of data I can back up. Maybe if we delay introducing vectors, we give the kids time to adjust to some physics concepts before they see this math that they struggle with. And by the time we get to vectors, they've got some understanding of classical mechanics already, so they're a little better prepared to deal with the additional vector math. So we go through energy-based mechanics, then we do force-based mechanics, maybe the things have a little more sense to them. It's possible that students who struggle with mathematics early on stop caring about the physics, and they focus on, let me get the math figured out. And so they're not doing as well on the physics concepts anymore because their worry is, can I decompose a vector, yes or no? Or what is the sign function? And maybe force-based solutions aren't as general as energy-based solutions. And so the students aren't learning as broad a applied physics problem-solving framework as they are when they're using forces. What's kind of fun is you can find literature that talks about students' perceptions about things. Again, frightening literature to read. But students repeatedly demonstrate a knowledge of energy that is more closely aligned with how we think about energy than students' knowledge of forces. Students always think you've got to keep applying a force to make something keep going. Whereas they understand that energy is this thing that I associate with motion or position. Even our chemist friends use energy in kind of the same way we do. So our students come in thinking about energy closer to how we want to think about it than they do with forces. Scalars are easier than vectors, so maybe we can help them ease into classical mechanics with a simpler math framework. As Sarah mentioned, we have a common problem-solving framework for everything that involves a lot of calculus. So maybe the students are getting a lot of calculus practice over and over again as they go through. As Alice said, one of the conclusions here is that we would strongly recommend that engineering students take Physics 211 over Physics 210 because they're likely going to do better in their downstream courses here or in engineering. Why that's true, we could talk about for future experiments. So it'd be a lot of fun, for example, to develop some kind of math assessment similar to what Jennifer's doing in the labs that we could use to test math ability. Can we rule in or out, is there any improvement in math ability for the students? This gets kind of tricky because I think what we really need to focus on is applied mathematics skills rather than just purely computational skills. And most math assessments are just computational skills. We should switch to 10 over to the energy first curriculum and see if there's any difference. If there is a difference, then we argue it's the curriculum and not the credit hours.
Or switch the other way around.
Or the way around and see what happens. We could also have all the engineers take 211 one semester and then look downstream and see what happens. I don't know how to play these games with advising for people because I think that's extremely dangerous and telling someone what to do with regards to this course. I also don't like the idea of running 2 sections of 210 that do different things. I think that's just going to cause all kinds of problems. But we should think about, should we switch one of these around one way or the other and then do it for 3 or 4 or 5 semesters and see what happens downstream. We could think of additional ways of incorporating. What?
We have a lot of experience with force first and 211. I don't know if you can go back that far to get data.
You can, and what you see, okay, yes, you can do that analysis. And what you see is that when we switch to energy first, the kids are now doing better. The problem with that is that I'm looking at downstream courses in engineering. If those engineering courses change at all, then my data is now meaningless. And they've done a lot of curriculum reform in engineering. So I can't say 10 years ago, kids who got this grade in 211 got this grade in ME 312, and now it's different because ME 312 has changed. All I can do is look at kids who go through now in this pair, what happens. But yeah, if you look, if you plot like these grades, you look at 211 before, what happens is that the kids in 211, the new 211 go up, and the kids in 210 stay the same or go down a little bit. But I don't know exactly how to interpret that. And we should do more math everywhere because math makes everything better. Okay. We should also think about investigating. We've changed 211 around. Is there any difference downstream in our own courses, upper courses? 521. Is this any different at all? Yes.
So when I was here at the undergrad way back, there was a specific, it was called honors, but it was really for physics students. So
yeah,
what
213.
fraction of physics majors even grade 211?
Right. So we have currently the way it works out is that 213 is the honors course, and so you have a lot of our majors, but also a lot of honors students from other majors. So I've not taught 213 in a long time, so I don't know what the breakdown is for how many of them are our majors, how many other majors. We're trying to change it around now to make it only our majors, physics and astronomy, any physics. But we could think about looking, has there been any effect in our downstream classes in our department? We also could ask OIRP, what do you know about DFW rates for these different courses? And the reason why that could be interesting is because if you look at DFW rates, and here's the enrollment numbers for these classes, some of these classes are kind of on the university's hit list for courses that are failing too many people. So do we have any effect on students' math ability? So if a student takes 210 versus 211, and then takes math 127, calc 3, are they more or less likely to do well in that class? If we are improving how well students do in ME 312, are we reducing the DFW rate in that class? And if so, what impact is that having on the enrollments in engineering? I mean, some of these classes aren't such a big threat, but a lot of these classes are above 10% DFW. If we can begin to move the needle on some of these classes, that can have a nice positive impact for the whole university. And so again, these are the numbers for some of the students there. Okay, so thanks for listening to this really long talk. Sorry I went over. Phil and Michael and Steve and Judy are the ones who taught 211 and 210 all these times. All the OIRP work was sort of funded by the KU STEM Analytics program. We got money from AAU, which got money from Northrop Grumman. So they're interested in how to make science education better. So they gave us money to think about how we track performance through our curriculum. We've had a lot of questions so far, but any questions for me or for Sarah?
What's FCI stand for?
Force Concept Inventory.
And what's the acronym mean for wherever the university all needs grade information?
What is the what?
All the grade information.
OIRP, the Office of Institutional Research and Planning.
Oh. You have a little acronym list.
Oh, sorry.
Slide, so.
I'm used to biophysics where we just speak in acronyms constantly and assume everyone knows. Yes?
Can you remind us, so you said for the ACT scores 30 and above, all of those students every single one of them got an A in all of those downstream courses, or what was the statement?
Students who took 211 or 210 and then one of those downstream courses, so those match students. If they had an ACT math score of 30 or above, they got an A.
In all of the downstream courses considered?
Yes, but it's not that there's one student who took all the downstream courses. I'm just doing pairwise matching.
But every single one of them, any downstream courses of those types, they got it.
Of the ones that I talked about, yes.
And how many were those? I mean, not in these courses. How many students were there?
It varies from class to class, but it's.
But like, of the kids that got an A that aren't included in this, it was like 10, 20?
So for this, For these, it's about, well, for these, I guess more than, it's about 15 to 20. Once you get into the larger enrollment classes, it gets a little bit larger, 25 to 30. But these are numbers I'm giving you are approximate. I have to go back and look at the spreadsheet to see like what they are. There's also an issue here in that, Sarah pointed this out, that there's an ACT grade threshold for financial aid at KU. And some students, once they hit that, they might not keep taking this. What we did was we looked at the highest ACT math score the student earned on any test. Some of these students have multiple tests. And so I don't know what to do if someone has a 27, 29, and then 30. I said that's a 30. But it could be they had like a good day. I don't know. Yes?
Getting back to when the split happened between 210 and 211, it's my understanding that the physics department was concerned about poor performance on calculus. But it appeared that physics was not checking for prerequisites. It seemed like there were a significant number of people in 211 back in those days that didn't have the prerequisite. And of course, engineering students were demanded to have that prerequisite because of the way they're advised. And how is that skewing things here? That
the prerequisite is the same.
We had students in 211 back then that didn't have the calculus prerequisite. So therefore, of course, they were using calculus.
So I'm comparing just when we broke off 210 from 211, and since then the prereqs are the same for both of the classes.
But are they checked?
I'd have to go check with Kristen about that. But if they're not checked for anything.
That's true. Yeah.
So I think that comes out in the
But
wash.
the engineers would have. I mean, they can't progress if that.
Sure.
We have prerequisite checks. So unqualified students don't show up in 210.
Right, but if you, right, so that, but that would only bias the distribution in a way that's opposite the results that we showed.
Right, but he's talking about before 20.
But the reason,
Yeah. Right.
But there was a year that we started checking, I think, so we should figure out what that year was.
Yeah. Yes.
Is there any old 211 with courses to physics 521/621 that you can compare with 211 energy to this?
We could make a request to OIP to do that, yeah.
Because I don't know, like, if they've changed really at all.
I don't know what's happened to 521 or 621 because we'd have to go back now, 3 or 4 years.
The problem is too grade inflation, right? And so by comparing 210 and 211 into the same class, you're saying these two got the different treatment, but yet they're going into the same course year. So that's why it's hard when we only had 211 to say anything about it.
Okay, thank you.